There's one other version of calculating concentration that you need to know, and that's called percent by mass, or mass percent. And mass percent expresses concentration of solute in terms of a percentage by mass. So the equation you use is the mass of the solute divided by the total mass of solution. So unlike molarity and molality, which were based off of moles, this is not based off of moles. It's just based off of the mass of solute. And sometimes you'll see this. This is what you're more likely to see in non-scientific contexts, sometimes in scientific contexts as well. But like if you see percent fruit juice or something like that, like what percent of your fruit juice actually came from fruit, this is where you see that information. It is similar to percent composition of a compound. So doing an example problem here, what is the mass percent of 165 grams of sodium chloride in 315 grams of water? Now notice the denominator here is the total mass of solution again. We're adding up the solvent plus solute together. So if we want to calculate the mass percent, the mass of the solute, the sodium chloride, is 165 grams, so that goes on top. Then we need to know the total mass of solution on the bottom. So we have to take both the sodium chloride into account and the water into account. So we need to add those together before we multiply by 100. So we end up with 165 divided by 480 times 100. And to 3 sig figs, that works out to be 34.4%. Let's do another example. Find the mass percent of 156 grams of potassium fluoride in 500 grams of water. Again, we need to think about the mass of solute, which is going to go on top. And then the total mass of solution is going to be the solvent plus the solute. And that's going to go in the denominator. So mass percent is 156 divided by the 156 added to the 500 before you multiply by 100. So we have 156 divided by 656 times 100 equals 23.8% if you round your answer to 3 sig figs. I hope this helps.